The next presentation is it's going to be a representative from MIT, the Massachusetts Institute of Technology, Sensible City Labs. We had Professor Carlo Ratti in the program. However, he was unable to attend for a last-minute problem, but he sent one of his lab directors as well, and his name is Dr. Dietmar Offenhuber. I hope I pronounced that well. Dr. Offenhuber is a media artist with a background in architecture and an interest in spatial concepts of cognition, representation, and behavior. Before I continue with his CV, I want to tell you a little bit about the MIT Sensible City Labs. This is an initiative that is studying the cities as living laboratories. So in other words, using the individuals as transmitters, and he will explain better. But we thought that this would be a great addition to the program because it's really innovative technology and merging of data to understand the city and the impact of the environment in the quality of life. So Dr. Dietmar holds degrees from University in Vienna as well as from the MIT Media Lab, and he was a founding member of the Arts Electronics Future Lab. In 2004, he was a Japan Foundation Fellow at the IAMAS Institute in Japan, followed by a professorship for animation at the University of Applied Sciences in Heidelberg. From 2006 to 2008, he worked as a researcher at the MIT Media Lab. Currently, he is a professor at the Art Links and key researcher at the Ludwig Institute for Media Arts Research. Dr. Offenhuber leads most of the sustainability initiatives at the MIT Sensible City Lab, and he recently won an award from the National Science Foundation. So please welcome Dr. Offenhuber.
Thank you very much for the kind invitation. I have to say I'm not a doctor yet, so it's going to be a couple of more months. But nevertheless, I'm very happy to be here. I hope you all enjoy your lunch. And I'm going to talk a little bit about the work that we do at the Sensible City Lab. So, there always has been a large amount of speculation about the relationship between technology and the city. So one of the very persistent ideas is that communication technology will lead to the dissolution of cities, that cities will disappear because of the telephone, because of the internet. This is already Frank Lloyd Wright in the 1930s wrote about that in his Broadacre City text, or famously Marshall McLuhan, who specifically coined the term of the global village that will make cities obsolete. And as late as in the 1990s, there was still this idea that we are headed for the death of the cities. That cities are a leftover baggage of the industrial area because of the internet. Well, as we all know, this is not the case. Cities are thriving, and we all know that more than half of the world's population is living in cities right now. So obviously, this connection between technology and urban development is not as straightforward as many people thought. And this is the topic that we are interested in the Sensible City Lab, about these very complex interactions between objects, devices, people, and urban space. And so the Sensible City Lab is part of the Urban Studies department at MIT, the same department where Kevin Lynch in the 1950s and 60s did his famous studies on the perception of the city. And our work is pretty much along those lines. how can we make sense of the city through the help of technology? For example, we are looking specifically at technologies that help us understand how the city works, but also come up with new technological tools to improve our cities. I'm going to start with one of the earliest projects from the Sensible City Lab from 2006. So Seseable City Lab was among the earliest labs that worked with mobile phone data to analyze cities. So we all know that when we use a cell phone, we leave a lot of digital traces, which can be also a big problem. But if this data is aggregated and lumped together so that no individual information is visible anymore, then we get a different pattern that tells us more about the city as a whole. And this project was presented at Venice Biennial in 2006 and worked with data from Telecom Italia at the city of Rome. And I'm going to show you a small anecdote of this from this project. While the project was on show at the Biennial, there was the World Cup final between France and Italy in Berlin, and as you saw, all of Italy was in front of the TVs, and was also, of course, discussing the game on the mobile phones. And we found it was very interesting to see how all the events of the games, how this like choreography of this suspense was reflected very directly in the way how mobile phone data was accumulated. So you have this famous, this is now already the next day, but you see that this famous incident where Materazzi was hit by Zidane with his famous headbutt, and suddenly the whole city, the mobile phone activity went up with excitement. So this shows us that there's a very direct connection between, of course, the behavior of people and the use of mobile phones, so that we can use the data from mobile phones as a proxy for understanding what's going on in the city. But of course we can go a little bit further than that. By digging a little bit deeper into the data, we can, for example, by looking at acceleration vectors, we can find out where in the city are pedestrians. And those are just the red areas in this representation. And the yellow dots are GPS traces from the public buses. So just by looking at this animation, you see that there is there's a suggested relationship. So what if we can make the public transport system more efficient by taking this information into account, that the buses go where the people are and not the people chasing the buses. The next project also again works with telecommunication data, but now on a global level. Here with the example of New York that is shown in the MoMA in 2008. And this project focuses on the connection of New York to the rest of the world as expressed through its communication over data and wireless usage and mobile phone usage. And of course, we all know New York is a global city, but when we talk about globalization, we always look at big financial institutions that make business around the world. But a second aspect of globalization is also the huge labor force in New York of immigrants that are constantly in connection with their families at home in the Dominican Republic, in Asia, in Latin America. And this is also something that is very, very represented in this data. Actually, one of my colleagues, Francisca Rojas, did her PhD on this project, where she really looked at these possibilities of using mobile phone data as a way to understand the demographic situation of the city. So, this is a very interesting visualization where you see New York divided in these small cells, and each cell contains something like a barcode that represents the destinations of telephone conversations from this tract. And as you would suspect, this closely matches the demographics of the immigrant communities, for example. You really see one of the, I think one of the most frequent destinations was the Dominican Republic, and those are families who are constantly using the cell phone to stay in contact with their families at home. Some of them are really even almost like raising children in a different country while they're working in the United States. So this shows a very, very vivid picture of how communication changes our lives. But of course there are also other sources of information, not just mobile telecom data. For example, health records give us a very good understanding of which symptoms are related to each other, how does the network of all these diseases look like. This is based on medical records. And then we created this kind of network visualization that clearly shows you which symptoms are related to each other based on these medical records, and give us a better understanding of these relationships. Another example would be financial transactions. This is a very recent project from Spain, from the BBVA. Here we see how people use their credit cards in Spain during the Christmas holidays 2 months ago. And it's really interesting how you see that one day before Christmas everyone rushes to the shops and buys stuff. And then on Christmas Eve everything gets quiet, and then people go out to restaurants again and start spending money. So our lab is very much interested in looking at these incidental pieces of information to inform urban planning and infrastructures for sustainable cities. But what if we don't have any data sets available that are generated by infrastructures that are already in place? What if we deal with an infrastructure that is characterized by a very severe lack of information, such as the waste removal system? This was a project that I was spending many years working on, Trash Track, where we basically investigated the waste removal chain, understanding what is where does garbage go. So what you see here is a glance into a material recovery facility, where you see that single stream recycling material is separated by hand into the individual different material streams. And this is very much how it also worked 100 years ago. So this is the recycling system in New York in 1903. Again, we see like a conveyor in the center, and you have a lot of manual labor separating out the valuable elements from this waste stream. And back then, the city of New York was able to finance their solid waste management, their garbage collection system through the revenues from this recycling system. But of course, this lack of information creates a strong sense of invisibility, that we are dealing with an infrastructure that people do not clearly understand, and where also professionals would like to have more information than you actually have. So our approach here was to follow individual items of household garbage. There are statistics collected by the EPA in certain intervals that collect quantities that are processed at a specific facility, for example, but no available data really shows how all these different facilities and locations and companies work together. What is the trajectory of an individual object through this system? And the only way to find this out was to look at active location sensors. Those are, you could say, a little bit like small cell phones that use the cell tower IDs from the telecommunication infrastructure to identify the location, and then use the same infrastructure to send this information back to us. This is a small example of objects that we tagged. We basically focused on household items. We did not look at industrial waste, but we covered everything from beverage containers to electronic waste. And yeah, my colleague Asaf operating on a teddy bear. And one aspect that became more and more important throughout this project was the involvement of volunteers. Initially, we were depending on the volunteers to really have the opportunity to distribute our sample evenly throughout the city. So we identified people, households that would allow us to tag the trash. But we were really overwhelmed by the response from all these volunteers who really had this strong desire to understand more about the waste system and see whether it was treated in a correct way and where these objects would eventually end up. And this is an example of a woman, a household that we visited, and with the objects that she prepared for us. We had a kind of a wish list that would make sure that we cover everything that we want to follow. And this is what we got after 6 months after the deployment. So what we see here is that the waste moved all over the country, and most interestingly, all those long traces that we see, the blue and the red ones, are household hazardous and electronic waste items. Of course, I mean, this is because there are relatively few dedicated facilities for treating electronic waste. At the same time, this is the most difficult waste to recycle, but also the most profitable. So we looked a little bit closer at these traces. Sometimes you would see funny things. For example, 2 printer cartridges that ended up in the same facility in Mexico, but they started in very different locations in Seattle, and they took very different routes. One went down through California, the other one, surprisingly, first went to Chicago and then by plane to the same facility in Mexico. So we see there are a lot of unpredictable and sometimes seemingly erratic movement in the waste system. But just the traces are not enough. We have to really understand what companies, what facilities, what kind of wastes are processed in these facilities. So we so we cross-correlated, we matched the geographical traces with a database from the EPA that contains all the facilities that manage waste. And with that, we could infer the network of facilities, of companies, of waste streams that treat different kinds of waste in different geographical areas. Of course, a very important aspect was also to understand the contribution of transportation to the environmental impact of recycling and waste management. And as you might have guessed with the example of the printer cartridges, there were some cases where the transportation cancelled out the benefits of recycling. So the way how we really collect waste, the way how we transport waste is more important than is often assumed. So Seseable in the United States is a very advanced, uses a very advanced waste system, a system that is planned top down by civil engineers. So we were wondering how would the same experiment look like in an informal waste system. This was a project that started right after Trash Track, but was completed only recently. We worked with the University of Sao Paulo with waste cooperatives in the city of Sao Paulo. And yeah, this is the waste cooperative Copamare, who have their facility underneath a freeway, a place where they bring together all the material that they collect in the city, sort it, and sell it back to industry for a higher price than each individual collector could achieve his personal work alone. They use both trucks and manual carts for collecting recyclables from the city. But one of the interesting aspects is that these informal systems, they work with tacit knowledge. So there's very little documented information, there's very little knowledge documentation, formal planning. For example, this calendar that contains all the destinations, all the facilities where the cooperative gets their recyclables from, is the only written document that exists inside the cooperative, and it's only used by the driver of the truck. Nobody else really understands and is involved in this planning of the routes. So in our project, we tried to document this tacit knowledge and to compare how does the truck collection compare with the manual collection. And here you see the blue traces are the collection routes from the truck, and the yellow from the manual collectors. And both have their advantages and disadvantages. For example, in Sao Paulo, after 6 p.m. you cannot use a truck in the city because of regulations. At the same time, the manual pickers, of course, they cannot cover the same distance, but they are also more flexible in their choice. So we wanted to understand a little bit better about what is the logic behind these spatial patterns and identifying all the destinations, all the clients, and interviewing together with the manual collectors, trying to understand their spatial decisions. And Chico, this individual picker, explained us. For example, he would not cover the area that's here on the right because there's like steep hills and he cannot carry his cart up there. Here there would be too much traffic, so it's really dangerous to use his cart on the street. Here there would be mainly residential areas, so it's not really a lot of material to recover. And here in these streets there are many shops, and this is the area where he gets all of his material. And interestingly, on average, he collected the double amount per person compared to the truck collection. So we did this participatory design workshop with the cooperative to come up with a system that would allow residents to inform the cooperative of material that they have to donate, so that there is a kind of direct coordination happening between companies, between local residents and the cooperative. This is a part that we are still investigating together with the network of cooperatives in Sao Paulo. And along similar lines, this approach to look at peer-to-peer coordination between service provider, between infrastructure and the users of this infrastructure is a very powerful aspect that can bring in a lot of also a kind of bottom-up dynamic in the whole process. This is a project that we are working on in Bolzano, in the northern part of Italy. It is a region that has a lot of small local farmers that produce food and sell it on the markets in the villages in the area. So it's a very mountainous alpine region. And they had this problem that it's for tourists and also for many locals, it's very difficult to find a specific farm or a specific product, because they all have like tiny quantities, but there are many of them, and there's kind of a need for a better coordination. And we are working on a system that allows the farmers to see where the people are and vice versa, to connect those two different groups. Finally, I want to conclude with a project that is also a very good example of our work that we do in partnership with different cities. This was a project that we did with the city of Copenhagen in the year when there was the climate summit in Copenhagen. It's part of an ongoing collaboration. And as we, in previous presentations today, we saw that Copenhagen is a very bike-friendly city. There are actually in Copenhagen more bicycles than inhabitants. But the city is very ambitious, and they want to increase the convenience for biking in the city to even raise the percentage of people who use bike for the daily commutes. And there's a second aspect that we can also use bicycles as a way to collect data in the city. What if you imagine every person who is using a bike as a sensor who collects information about pollution, about noise, because those are at the same time the people who are most affected by these environmental impacts nuisances. Of course, we didn't want to go that route where we stuffed all this bunch of sensors on a bike, and you really, this would not be something that people would like to use. Instead, we combined everything in the back wheel of a bicycle, and so this is a hybrid bicycle that doesn't drive on its own. You have to pedal, but if you pedal, the motor in the hub compensates the power and augments your power. So you could say that it supports you when you go up, and when you go down, it even creates some kind of friction. So you always can recover a lot of energy, but also ride with the greatest convenience. And the interesting thing was that this project originated from a student workshop. This is a very important aspect of our work, where when we work together with cities, it's usually a 3 to 5 year partnership at minimum. And in the beginning, we always start exploring a topic with students and come up with different routes of investigation. And this is a recent development that is now also being commercialized.
Welcome to the Copenhagen Wheel. The wheel that turns your ordinary bike into a smart electric hybrid. Quickly and easily, with no additional batteries or wires. The Copenhagen Wheel allows you to capture the energy dissipated while braking and cycling, and save it when you need a bit of a boost. Controlled through your smartphone, the Copenhagen Wheel becomes a natural extension of your everyday life. The Copenhagen Wheel is your personal trainer, sensing your effort level and providing you with real-time feedback about your fitness and exercise goals. The Copenhagen Wheel also enhances your experience in the city. It connects you with things a cyclist wants to know: upcoming traffic congestion, road conditions, and pollution levels. Choose to keep your data, or share it with your friends and other cyclists through social networks like Facebook. As you ride, you also collect green miles. It's similar to a frequent flyer program, but good for the environment. Elegant, responsive, smart. A new mode of transport for a rapidly changing world. So turn on your life and turn on the city. The Copenhagen Wheel.
I also want to share a second short video from the climate summit in Copenhagen and mayors used this guy and tried it out. This is a recent edition where we developed a social platform where different users who use the Copenhagen Wheel can coordinate with each other. So concluding, in what we saw in all these projects, one of the big advantages of digital technology is that it makes it very easy to coordinate between people and to plan together without the same necessity for centralized systems. Of course, eventually we always will need hybrid systems that contain top-down and bottom-up elements. But what we are investigating here is what elements can be really crowdsourced, so to say. What parts of infrastructure can be distributed to a digital collective. One aspect that we saw in Trash Track, for example, was the example of distributed monitoring. If the citizen has the means to scrutinize infrastructure provided by the city or by a large company, they can. This would be something that Larry Dietmar would call accountability technologies, to collect information, to make sure that everything goes well. And a second level that would involve a little bit more than just observing an existing system would be using technology to improve the coordination in a peer-to-peer way. The matching market project from Bolzano would be an example of that. And the strongest form of distribution would be that if tasks of maintenance, if action is actually distributed, for example, in the Copenhagen wheel, where we reach a point where really the boundary between a service provider and the citizen and the consumer is starting to blur. And the word participation is a little bit overused, but in our understanding, participation is more than just asking the citizen for feedback. It means that the citizen also takes up certain responsibilities and really becomes part of the system and has the ability and the power to shape a small part of the system. So all these projects are parts of these partnerships that we have with cities, with cities like London, Madrid, Rio de Janeiro now, currently. And I think I'm going to stop here and open up for questions. Thank you very much. It's right now, I think there's the first batch is produced now. Like there are like 200 Copenhagen wheels right now, but it's in the process of. Many other cities says, well, it's said that it's a great project, but can we give it a different name? We don't want a Copenhagen wheel in our city.
I'm curious to know whether your measurement technologies are primarily used for planning purposes or ever you are doing real-time management, like, for instance, transportation networks, where you might want to know where real-time demand is changing through the day?
I mean, this is. I think this is a part that needs to be very carefully calibrated. How and in what way information is collected and who has control of this information. So I didn't show the work that we did in Singapore, where the goal is more to optimize an existing transportation system by using this real-time technology to balance load and things like that. So it always depends on the existing infrastructure, on aspects of privacy, and on ultimately what people want and can do with this data.
And for people who would like to read more, have you published much in the way of results, or is your work product pretty much the property?
Yeah. So, I mean, this is also a part that in every project has this component of like there's a design part, but there's also a research part, and there are papers on most of these projects. I can if you contact me afterwards, I can send you. Thank you.